Hello, this is Ms. DB, and today we're going to continue our work with matrices in Chapter 4 and do Chapter 4, Section 4, which is on determinants and Cramer's rule. So we are going to find determinants of both 2x2 and 3x3 matrices and then use Cramer's rule to solve systems of linear equations. We've solved systems of linear equations with graphing, with substitution, with elimination, and now you're going to learn another way you can solve them. So every square matrix, 2x2, 3x3, 4x4, etc., has something called its determinant. And a determinant is shown with these straight line brackets. So instead of the square brackets that shows that you have a matrix, this means determinant. You can find the determinant of a matrix, and we will use the determinant in using Cramer's rule and finding the solving a system of equations. So a determinant of a 2x2 matrix is just the difference of the products of the diagonals. So what you do is you multiply the first diagonal, 1 times 4, and you multiply the other diagonal, 3 times 2, and you subtract those numbers. So you'd have 4 minus 6, which is negative 2. So you multiply the diagonals, and you take the difference. You have to do the red diagonal has to be listed first, and then you subtract the blue diagonal. And again, we will write determinant either with it looks like an absolute value bars, but it's not. It's determinant, and you can either write DET for determinant, or you can put the capital letter of the matrix in those bars. All right, if we are finding the determinant of this matrix, all you have to do is multiply 1 times 8 and subtract 5 times 4. It's quite simple to find the determinant of a 2x2 matrix. You just multiply and subtract. The only mistake you might make is you might subtract in the wrong order. So it's always top left to bottom right, and then you subtract the bottom left to top right. And so we get negative 12. You can do the determinant even if there's fractions. 1/2 times 2 is 1, and then negative 1/2 times negative 1 would be 1/2. So we would have 1 minus 1/2, which is just a half. All right, now why would we need the determinant? We're going to need the determinant in order to finish this lesson on Cramer's rule. So remember that you can write a linear equation in standard form as ax plus by equals c. And if we do that, then we can make a matrix with the coefficients of the variables. So if we have a system of equations where it's a1x plus b1y equals c1, and the other equation is written in standard form as well, so we could write that as a2x plus b2y equals c2, then we make a coefficient matrix where we have our x coordinates in the first column, and our y coordinates in the second column. Now, note this is different than when we translated or transformed an image where we had our x coordinates in the top row and our y coordinates in the bottom. In this one, our coefficient matrix, the x coordinates will be in the first column, and our y coordinates, our y coefficients will be in the second column. So this is a coefficient matrix, not a coordinate matrix. Coefficient. You also will need to find the determinant of this matrix, and we know how to do that. Once you are able to write your coefficient matrix and find your determinant of it, then we can find our solutions. And here's how you find your solutions. To find x, you take your coefficient matrix, which was a1, a2, b1, b2, and you replace the x coefficients with the right side of the equations, what they were equal to, the constants. And then you leave the b1 and the b2, and you take the determinant of that, and you divide by the determinant of the coefficient matrix. To find the y coordinate for your solution, you leave the x coefficients where they were, you take the y coefficients out and replace them with the constants. Find the determinant of that matrix, divide by your determinant of your coefficient matrix. All right, let's look at it in action. Oh, you can also use Cramer's rule to tell whether the system has one solution, no solutions, or infinitely many. So as long as D, our determinant, is not equal to 0, we're going to have one solution. So you continue solving. If you get D equals 0, and at least one numerator determinant is 0, then your system is dependent and has infinitely many solutions. If D equals 0 and neither numerator determinant is 0, the system is inconsistent and has no solutions. All right, we're going to start with this example. So our coefficient matrix is going to be 2, 3, 1, negative 2. So we start by writing that and then finding the determinant of that. We're going to use D several times in the next steps. So the determinant is 2 times negative 2 minus 3 times 1. And when we do that, we get negative 4 minus 3 is negative 7. This is our D that we will use many times in the next few problems. I'm just going to write down our equations in case they're not on the next page. My memory doesn't always last forever. So since D is not equal to 0, we know that we're going to get one solution here. All right, now here's where they did not rewrite the equations, and I'm going to write them up here. Our original equations were 2x plus 1y equals 10, and 3x minus 2y equals 8. So our coefficient matrix, before we took the determinant, we had written this, is this. This is our coefficient matrix. And we are going to, in order to find x, we replace the x coordinates, the x coefficients, 2, 3, we replace them with the 10, 8. So the 10, 8 will go here. The negative 1, negative 2 stays in this matrix. And we are going to find the determinant of this and then divide by our old determinant, which we found on the last page as negative 7. All right, so now we take 10 times negative 2 minus 8 times 1. So 10 times negative 2 minus 8 times 1. So that's negative 20 minus 8 is negative 28. And we divide that by negative 7. That's where we got the 4. Now we know that the answer, part of our answer, is x equals 4. All right, the next part that we do is we find y. To find y, we leave the 2 and the 3 here, 2 and 3, but we replace the y coefficients from our original coefficient matrix with the 10 and the 8. And then we define the determinant of this matrix. So we take 2 times 8 minus 3 times 10. So that's 14 minus 30. 16 minus 30 is 14, negative 14. And then we divide that by negative 7, and we get 2. So y is equal to 2. So now we have an answer to our system of equations of 4, 2. Now you might say, well, I would just use substitution or elimination, but sometimes this method works better. This is called Cramer's rule, and it's a way of using matrices and determinants to find a solution to a system of equations. Here's another example. So again, we start by writing our first of all, we have to start by rewriting these in ax plus by equals c form, because I just looked at this and this is not in this form yet. So I would subtract 2y from both sides, and then I would subtract 5. So I would move this over this way and then change this to this. And then in the second equation, I need to subtract the 15 and add 9x. So I would get 9x minus 6y equals negative 15. So that's your first step, is to make sure they're in standard form first. Once you get them in standard form, then we can go ahead and we can use our Cramer's rule in order to write the coefficient matrix and find the determinant of that. So my equations, I'm going to write them up here again, were 3x minus 2y. This was after they were written in standard form. And the other one was 9x minus 6y equals negative 15. So our coefficient matrix would be 3, 9, the x coefficients, and then negative 2, negative 6. So we find the determinant of that by taking 3 times negative 6 is negative 18, minus 9 times negative 2 is negative 18 as well. So negative 18 plus 18 is 0. Now remember, something special happens when you have a determinant equal to 0. It means that we're either going to have an answer of infinite solutions or an answer of no solution. So we have to continue a little bit farther and find out whether or not we get a 0 when we do our next determinants. So to find the x value of our solution, we replace the x coefficients with negative 5, negative 15, the c values, the constants. So we would write negative 5, negative 15, and then the negative 2, negative 6. And we find the determinant of this by going negative 30 minus a negative 30. And that's equal to 0. So then we can stop and say, wait, so one of our numerators is going to be 0, which means that, well, we can go ahead and find this. This one actually also equals 0. So that means that we are going to have infinitely many solutions. We can't find x and y. There's too many answers, but we go ahead and say that there's infinitely many solutions. We can also use Cramer's rule for a 3 by 3 matrix. Before you do that, you have to know how to find the determinant of a 3 by 3 matrix. And you can see that it's a lot more complex than a 2 by 2. So to find the determinant of a 3 by 3 matrix, we have all these diagonals that we need to subtract. Another option for finding the determinant of a 3 by 3 is to use the graphing matrix, either your graphing calculator or to use the online matrix calculator. And then you just enter in your entries for your matrix, your 3 by 3, and then you hit to find the determinant of it, and it will find the determinant for you. Here's how to do it if you're going to do it by hand, but I would definitely recommend finding the determinant by using a technology. So in order to do it by hand, you have to write the determinant from the matrix. The first 3 columns are the same, and then you rewrite the next 2 columns after it, because we need those in order to find our diagonals. And then we would multiply the 2 times 2 times 8, and the 4 times 3 times 1, and the 1 times 5 times 4. So 2 times 2 times 8 is 32, and 4 times 3 times 1 is 12, and 1 times 5 times 4 is 20, and we add those numbers together and we get 64. Then step 2 is we also go up. So we have to multiply 1 times 2 times 1, and 4 times 3 times 2, and 8 times 5 times 4, and add those numbers together. So that's 2 plus 24 plus 40 times 4 is 160. So we end up with 186. Then step 3 is to take the 64 and the 186 and subtract them. That's your determinant. And then we check with the calculator. So even if you do it by hand, I recommend checking with the calculator to make sure, because these get pretty tricky. Once you know your determinant, then you can find your solution to your system of 3 equations using Cramer's rule. So here it is again for 2 equations. It can be modified a little bit for 3 equations. So here's how we will do that. This is an example. where we could write 3 equations from that problem. So here's the three equations that could be written from that problem. What we're going to do is find the determinant of our coefficient matrix. So we find our coefficient matrix, which would be 4, 1, 0. This is 0p plus 0f as well. Looks like of. And then 4, 1, 4, and then 9, 1, 0. And then we find the determinant using technology or that method that we saw before. And then we got 20 for that. Okay, that's your first step. Find the determinant, maybe your second or third step. Then you write your coefficient matrix, but you replace all of the x coefficients, or in this case it was what, p? Replace all of those with your constants. So 3,400, 680, 1,700. And then we keep the, what was this, PCF. And we would keep the C's and we keep the F's. And you find the determinant of this, I would say, using technology. And we divide by 20 because that was the determinant that we had. And then you divide and you get 119. That's your value for P. And then for C, we keep our P's. We replace our middle column, the C column, with your coefficient. With your constants, sorry. The right side. And then you keep your F's. And you find the determinant of that using technology, and you divide, and you get what C is equal to. And then finally, for D, you replace your F, usually it's X, Y, Z, but you replace that with your constants, your 3,400, 680, the right side, and you use your technology to find the determinant, and you divide by 20, and we would get our value for F. So really, this is a very strategic method and a valid way to find solving 3 equations for 3 unknowns. And it doesn't take any longer, maybe even less time than finding it with the methods that we learned in the last chapter. There's another video in your folder on how to do one of the problems from your worksheet, so you can watch that one to see how to do number 7. Good luck, and let me know if you have any questions, and we can work together to do this worksheet if you like. Thank you very much and have a great day.